Hey guys, it's Rishi once again. Welcome back to yet another maths video, where within this tutorial we'll be going through the highest common factors and the lowest common multiple using your prime factors. So now, in some questions, the highest common factor or lowest common multiple of two large numbers may need to be found. So in this video, we're going to be going through a number of different questions that will cover this entire topic using a more efficient method, which is to use prime factors. So now, just as we've covered in the previous videos, feel free to pause the video at any time and attempt the question before pressing play, where I will then go through the solutions. So without further ado, let's go ahead and let's get started. So now, before I go ahead and attempt question 1 here, I'm going to go through an example. So now, it would take a long time to write out all the factors, as you guys may have experienced, and multiples of, let's say, the numbers 24 and 180, and then compare the lists, and it would be very easy to make a mistake. So now, using prime factors to find the HCF and LCM can be much easier. Numbers can be broken down into prime factors using prime factor trees. And when the prime factors of two numbers are known, they can be compared to calculate the HCFs and the LCMs. And this can be more efficient than listing out the factors and multiples of large numbers. So now we've gone ahead and we've started off by writing 24 and 180. Let's now write the products of their prime factors. So we know 24 is made up of 4 and 6, but as they are not prime numbers, we're going to go ahead and dive a little bit deeper. So we know 2 times 2 is 4 and 2 times 3 is 6. Likewise, I'm going to do that for 180. Let's go for 18 and 10. We then have 2 and 9, but 9 is not a prime factor. So we go deeper and we get 3 and 3. And again, what I'm going to be doing is just circling all of my prime factors here. And then I'll do the same for 10, which is 2 and 5. So now we have the product of their prime factors. That's our step 1. Our step 2 here is going to be writing it out. So if we take a look at 24, we have 2 to the power of 3 times by 3. And that's because there are 3 sets of 2. And now for 180, you can see that we have 2 sets of 2s. So that's 2 squared times 3 squared times by 5. And that's a way that you can write your prime factors down. But what I'll do is I'll just simply go ahead and write it out once more. So that's for your 24. And then for 180, marvelous. So now, to work out our highest common factor, we need to find any prime factors that are common between the products. And each product, you can see, contains 2 sets of 2s here and 1 3. So we can use these for the HCF. So now we can take one set of the copy, which means we'll go for a 2 from here, a 2 from here, and a 3 from here. And that's just one set of the copy. So now we know this equals our HCF, which equals 12, because 2 times 2 times 3 gives us 12. And now we can cross any numbers used so far from the products. So again, we can cross out the 2s that we've used and the 3s. And that's both from the products of 24 and 180. And now to find our LCM here, we need to simply multiply the HCF, which was 12, by all of the numbers in the products that have not yet been used. So that's again 2 times 3 times 5, and that gives us 360. And that's a way to work out both the highest common factor and the lowest common multiple. And now as we go down, you'll also be seeing Venn diagrams that are going to be showing the relationship between different sets or categories of data. I hope that was a clear introduction. Let's now go ahead and recap this once more with a series of questions below. And just to reiterate once more, if you guys feel confident about this specific question, go ahead and pause the video now, attempt it, and then press play, and we'll go through the solutions. All right, let's get started. So the first question states to write 40 as a product of its prime factors. So again, as I've done above, I'm going to go ahead and start off with the number 40, and I'm going to write out my factor tree and that will give me 8 and 5. Again, you don't have to choose 8 and 5. You could even gone ahead and done 20 and 2. Does it make a difference? And let's show you that we get the same answer at the end of the process. So we know that 8 is a prime number, so we'll get 4 and 2. 2 is, so we can circle it, but 4 is not. So we dig deeper. Now you can see that the products of 40 as a prime factor would be 2 to the power of 3 multiplied by 5. So let's take a look at this second pair here. So we've got 20 and 2. We know 2 is a prime factor. So let's dig deeper for 20. So we can get 10 and 2. Again, we can circle our 2, but 10 is not a prime number. So we'll go ahead and dig deeper to get 5 and 2. And once again, that shows we have 2 to the power of 3 multiplied by 5. So no matter what factor you choose of a number, you will always get the same answer at the end of the process. So all we need to write is 2 to the power of 3 multiplied by 5. I hope that was clear. Let's now move over to question number 2. Likewise, let's go ahead and write down the prime factors of 72 here. So I'll go ahead and start off by doing 36 multiplied by 2. Again, we'll have 18 multiplied by 2, and then 9 multiplied by 2, and then 3 and 3. And if we put that all together, we should now get 2 times 2 times 2 times 3 and 3. Or we can simply write 2 to the power of 3 because there are 3 2's, and 3 squared because there are 2 3's. And that's our final answer, 2 cubed times 3 squared. Wonderful. Okay, let's go for question number 3 here, and that's with 98. So again, let's pick 98, and we'll go for 2 and 49. We know that 7 goes into 49 7 times, and we know that's a prime number, so this is a short one for us. So again, we can write 2 times 7 times 7, or we can go for 2 times 7 squared. Brilliant. Okay, question number 4. Write 240 as a product of its prime factors. So again, if you guys want to go ahead and attempt this, feel free. But for those who want that extra level of practice, let's go through this. Okay, we have 240. Let's go for 24 and 10. And let's dig deeper, so we can have 4 and 6 and 2 and 5. And 2 and 2 and 3 and 2. So now if we put this together, we have 1, 2, 3 and 4 2's. So 2 to the power of 4 multiplied by 3 and multiplied by 5. And we can even take this a step further to check if we're right. Let's go ahead and calculate this. So if we have 2 times 2 times 2 times 2 multiplied by 3 and multiplied by 5, we know 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. So this gives us 16 here. You can then go ahead and multiply 16 by 3, which gives us 48, and then 48 by 5, which gives us 240. And as you may have seen in our previous video, the shortcut that I had provided, you can simply go ahead and multiply 48 by 10, which is 480, and then divide it by 2, which gives us 240. Or you can simply go ahead and half 48, which gives you 24, and add a 0 at the end of the number. Okay, let's move over to question number 5. And that's where they're asking us to find the highest common factor of 60 and 114. And in this particular one, I'm going to bring in a Venn diagram. And again, remember that is simply showing us the relationships between two sets of numbers and different categories of data. So let's go ahead and dive into this. So again, I'll start off with my 60 and my 114. We can know we have 6 and 10 and 3 and 2. And that gives me 2 and 5. So now I have 3 times 2 squared times by 5. Let's now go ahead and do the same to 114. And we can go in 2, 4, 57, and then 3 and 19. So 2 times 3 times by 19. Before finally going ahead and working out the HCF, I'll go ahead and write out a Venn diagram. So we've got 2 overlapping circles, one representing 60 and another representing 114. So as you guys had seen in my previous example, I went and picked out what is common between both numbers. So if I take a look here, and I'll write it out once more, you can see here that we both have a 2 and a 3 in the number. So because that is common, I'm going to put 2 and 3 in the center. And that's the intersection between 60 and 114, leaving the remaining numbers going in the relevant sections. So you can notice that 19 is in 114, but not in 60. So I'll place 19 in the 114 section and 2 and 5 in the 60 section. And again, if you remember, the way to calculate the HCF is to simply calculate the intersection, and that's the product of the intersection. So we know 2 times 3 gives us 6. And there we are. That is your HCF. So again, what have I done? Step 1, I've gone ahead and worked out the product of the prime factors for 60 and the product of prime factors of 114 before putting them together to get the common numbers. And then finally, placing them in the Venn diagram. So that's your 3-step method, giving you 3 marks for the paper. Okay, let's go down to question number 6. So now in question number 6 here, it's asking us to find the lowest common multiple of 120 and 150. So let's go ahead and write down our 2 numbers, and let's go ahead and write out the prime factors of each one. So now I've gone ahead and done that. That's my step 1 done. Now for step 2, I need to put them all together. So let's go ahead and write this out. Okay, brilliant. So we've written that out for each specific number. And now for step 2 here, I'm going to simply go ahead and highlight what is common between both sets of prime factors. So you can see they both share a number 3, they both share a number 5, and they both share a number 2. So now those numbers are common, so we'll go ahead and write that out in the center here. 3, 2, and 5. Leaving the remaining numbers to be allocated to the right places. So you can see 5 will go directly into the 150 section, and the 2 times 2 will go directly into 120. And that's our first 2 steps done. And now for the final step, in order to calculate the LCM, you're going to get the product of all of the numbers within the Venn diagram. So let's take a look. We have 2 times 2, which is 4. We have 3 times 2 times 5, which is seen as 30. And then we have to multiply it by 5 here. So we know 4 times 30 is 120. We times it by 5, that gives us 600. So now we know our LCM is the total product of all the numbers within the Venn diagram, giving us 600. Remember, it's still the same 3 marks here, so 3 individual steps. Wonderful. Okay guys, let's move over to question number 7. So now in this particular question, we're looking for the HCF of 84 and 120. So feel free to pause the video here, attempt the question, and then we'll go through it together. Okay, let's start with question number 7 here. Let's go ahead and once again write out the prime factors of both 84 and 120. So again, we can go for 2 and 42 here, 21 and 2, and then 3 and 7. So that gives us 2 squared times 3 times 7. And then again, let's go for 120. Wonderful, that's our step 1 done. We'll then go ahead and put what is common within the section here. We'll then go ahead and write out our prime factors. And there we are. So that's step 1 and step 2 done. Before going into step 3 and writing out what is common. So we can see they both share 2 here and they share a number 3. So now by doing so, let's write 2, 2, and 3 in the center. And that is because they share 2 2s and 1 3, leaving the 2 and the 5 to go in the section of 120. So that's 2 and 5. And then the remaining 7 which will go in the 84 section, and that's that there. So now we've gone ahead and done that. In order to find the HCF, guys, please remember we need to always find the intersection. So that is this part here, and that will give us our HCF. So 2 times 2 times 3 gives us 12, and that is our HCF. And finally, I'm going to take this a little bit further now. I know the question isn't asking us about the LCM, but let's go ahead and find out what the LCM is. So we now know that the HCF is equal to 12. So now we need to simply multiply 12 by 7 and 5 and 2. And those are our remaining numbers. So as it's our remaining number here, let's go ahead and multiply that all by 70, because 7 times 5 is 35, and 35 times 2 is 70. So 12 and 70 here. So again, let's go ahead and work this out. And that's 840. Beautiful. Okay, let's move over to question 8. Again, what is the lowest common multiple of 70 and 56? So let's go ahead and write out 70. Let's write out 56. Let's put our 7 and 10 here, and 2 and 5. So now we know it's 7, 2, and 5. And we can go for 7 and 8, which is 4 and 2, and 2 and 2. Marvelous. So now we've gone ahead and written that out. We can simply write 2 cubed times 7. And instantly, as you're getting used to this, you'll become more confident, and you can simply go ahead and write these out right away. So we've got 70 here and 56 on one side. We can see that they both share a 7 and a 2. So we put 7 and 2 here. We know, however, because there's 2 cubed in this section and we've taken 1 2 out, there are going to be 2 sets of 2's left, which we'll put in the 56 section, and then the remaining 5 will go in the section of 70. And now, because it's the LCM, we can go ahead and multiply everything in our Venn diagram. So we now know here that 14 times 5 is 70, and we can times 70 by 4, which is again 280. And that is our answer, 280, which is your LCM of 70 and 56. So what do? Step 1, you get the prime factors. Step 2, you find what is common. And then step 3, you put all the information in your Venn diagram. I hope you can see how quickly and efficiently we can both calculate the prime factors as well as the LCM. Okay, let's now go to something a little bit more challenging. And this is where we have our word problems. So 2 buses, both A and B, use the same bus stop. And bus A runs every 10 minutes and bus B runs every 14 minutes. And both buses are at the bus stop at 11 a.m. So what time will both buses next be at the bus stop? So let's take a look here now. So we're going to go ahead and take the prime factors of both 10 and 14. So again, if we take a look at 10, we will then get 2 times 5. And if we look at 14, we'll get 2 times 7. And then we're going to go ahead and put this in our Venn diagram here. So you've got 10, 14. Remember, that is your bus A, and that is your bus B. We can see that they both share 2, so 2 is common, which will go in the center. And then 5 and 7 will go in the right section. So now, because we need to find the LCM here, we're going to multiply everything within the Venn diagram. So again, we know 5 times 2 times 7 gives us 70, which is our LCM. So we now know that both buses will be at the bus stop 70 minutes after 11 a.m. So 70 minutes. So again, if we calculate that out, we have 11 a.m. We plus 1 hour, which is 60 minutes, and then a further 10 minutes. And now we know it's going to be 10 past 12. And there we are. 10 past 12. And that's when both buses will be at the bus stop at the same given time. Okay, let's move over to question 10. And this is very similar now, where again we have light A flashes and light B flashes at different times, and we want them to flash at the same time and find out how long it will take. So what do we do here? Step 1, we find out our prime factors of 8 and 20. So we know that's going to be 2 cubed, and we know for 20 it's going to be 2 times 2 times 5. And how am I working this out now? Well, I'm taking a look at 8 and I'm saying, okay, 4 and 2 times gives you 8 and 2 and 2. So that's my 8 section. And if we do 20, we'll do the same thing, 4 and 5 and 2 and 2. And there we are. I've now gone ahead and done that. Let's create our Venn diagram here. Let's go for A and let's go for B. We know again that they both have two 2's which are common, so that will go in the middle. And then the 2 for the 8 will go into light A, and the 5 from the 20 will go in the light B. And again, because they're asking us for how long it will take for both of them to flash at the same time, we'll go ahead and work out the LCM and simply multiply all of the numbers within the Venn diagram. So again, we know 2 times 4 is 8, and 8 times 5 is 40. So 40 seconds. So at 40 seconds, both lights will flash at the same given time. And now we can check this if we want to go a little bit further. So what I can do here is simply go ahead and write down my 8 times table. And I'll keep going until I reach a certain threshold. And then I'll do the same for light B, which is our 20 seconds. And you can now see here that the first number that occurs in both times tables is 40. And that's a quick way for you to check. But remember, we are avoiding this method as our main method because it takes far too long. But in this specific example, it's worked pretty quick. Okay, that's our question 10 done. Let's now go for question 11. We're almost done now, guys. Keep it up. We've only got 16 questions in this section. So they've now given us step 1 and they've calculated it for us. So they're now asking to work out the highest common factor of 648 and 540. So we can directly go ahead and draw out our Venn diagram. And let's go ahead and write out what is common between this. So just for ease of use, I'm going to go ahead and write out my prime factors of 648. So I've gone ahead and done that. 3 sets of 2 and 4 sets of 3. And then I'll do the same for 540. And now we can go ahead and put this all in our Venn diagram. So the first thing to notice now is that we only have one number of 5. And that is come from 540. So I can go ahead and put 5 here. And now let's see what is common. So we can see that we have 2 sets of 2. So again, we can put a 2 and a 2 here. I can now cross this out. And then we've got 3 sets of 3 here. And again, we can put 3, 3, and 3. And I can now go ahead and cross this out. So what are we left with? 2 and 3, which is from 648. And I can write that down there. And now that they're asking us to work out the HCF, I need to simply go ahead and multiply all of the numbers in the center. So that's 2 times 2, which gives us 4. Times it by 27. 4 times 27 gives us 108. And there we are. So that's 2 times 2, which gives us 4. And then 3 times 3 times 3, which gives us 27. And if we multiply the 2 out, we get 108. And that is our answer right there. Okay, let's take this one step further and let's find the LCM of both 648 and 540. So what do we need to do here? We need to simply multiply all of the numbers within our Venn diagram. So we know the center gives us 108. We now need to simply multiply that by 2 times 3 times 5, which again will give us 30. So again, we can go ahead and multiply 108 by 3 and then add a 0. So we know that gives us 324, add a 0, and that's 3,240. And that is our answer there. So what did I do? I multiplied it by 3 first. We know 8 times 3 is 24. We know 0 times 3 is 0, plus the 2, which is there. And then 1 times 3 is 3. And then adding the 0 because of this 30 here. And there's the 0. Beautiful. Okay, question 12. They've given us this very similar question as we've just done here. So let's go ahead and write out our Venn diagram. Let's label this as A and B. And let's go ahead and write out what we have. So let's go for what is common. Firstly, we can see that there's 2 2's here and there's 3 2's here. So I'm just going to put the 2 2's there, and I'll leave 1 2 here. And we can cross this out now. We can then see that 3 is also being used. And again, I'll put a 1 3 here. I'll cross this out and then put a 3 here because they had 3 squared, which is 2 sets of 3's. And now we can go ahead and put everything else in the right section. So because we have 5 squared here, we can have 2 5's in A, and the rest 2, 3, and 7 can now go ahead in our B section. And there we are. So now if we want to work out the HCF, let's go ahead and multiply out our middle section. So that's our intersection. So we know 3 times 4 is 12, and that is our answer there. And then once again, to find the lowest common multiple, we want to multiply everything. So we know we have the HCF as being 12. We know section A, which is 5 times 5, that gives us 25. And then we know for section B, we have 42 here. So now we need to multiply 12, 25, and 42. So again, let's go ahead and work that out. So we know 12 and 25 gives us 300. So now we need to multiply 300 by 42. So again, we know 300 times 2 is going to give us 600. We'll then put our place value holder and we'll do 300 times by 40. So we'll put 2 zeros there and we'll put 12. And that's 12,600 as our answer. And there we are. Marvelous. Okay, let's go for question 13. You're doing really well, so keep it up. And let's now find the lowest common multiple of 12, 15, and 18. So again, I'm going to go ahead and write out my prime factors here. And we can go for 6 and 2 and 3 and 2. And let's go for 3 and 5. And let's go for 9 and 2 and 3 and 3. Marvelous. And now because there's 3 numbers, we have to form an extra circle within our Venn diagram. So now I can label this as 12, 15, and 18. And let's see what's common here. Well, if I take a different color now, you can see that they all have the number 3 here. So that's going to go in my center. And we know that 18 is left with 1, 3. So that can now go at the bottom here. And let's also measure that both 6 and 18 share the number 2. So we've got a 2 here and a 2 here. So we can put a 2 next to the 3. And 6 has an extra 2, so I can put the 2 there. And if we just cross out everything that we've written out, we can see that 18 has got a 3 as well. So we can cross that one out because it's got 2 3's here, so we don't really need that. And then 15 has a 5, and there we are. We are all done. So now if we work out the lowest common multiple, we need to simply go ahead and multiply all of the numbers here. So again, if I take a different color here, we know 2 times 2 is 4, 4 times 3 is 12, 12 times 3 is 36, and 36 times 5 is 180. And there we are. Okay, let's go for question 14 now. So light A, light B, and light C, they all flash at different seconds. And all 3 lights flash at the same time. So work out how long it will take for all 3 lights to flash at the same time. So again, let's go ahead and let's draw out our Venn diagram here. And let's label this as A, B, and C. We'll then go ahead and write out how often they flash. Again, you can see that 5 is a prime factor, so I'll just put 5 in this section here, but 6 is not. So we'll put 2 times 3. And 7 is, so we can simply write 7. So let's go for 7 for C and 2 and 3 for B. So now we've gone ahead and done that. What do we need to do? Well, in many cases, we would need to go ahead and multiply all of the numbers. So let's go ahead and do that. We have 5 times 7, which is 35, times by 2, which is 70, and times by 3, which is 210. So you can see 35 times by 2 is 70, and times by 3 is 210, which means all 3 lights will now flash next at 210 seconds. Okay, over to the last set of questions now, guys. Find the highest common factor of 72, 90, and 126. So again, let's go ahead and write that out here. Shouldn't take us too long now. You know 9 times 8 is 72. We've got 3 and 3 and 2 and 4. And then 2 and 2. And then again, we'll do the same for 90. We do 9 and 10. You know, that's 3 and 3 and 2 and 5. Before going through to 126, which is going to be 2 and 63. And we can go for 9 and 7. And then 3 and 3. Marvelous. Okay, so now we've got that. Let's go ahead and find what is common and put that within our Venn diagram. So I'll label this as 72, 90, and 126. Okay, let's take a different color and let's pick one number first. And let's go for the number 2. So you can see that we've got 1, 2 here, another 2 here, and another 2 here. So 2 will definitely go in the center. And we can cross these out now because they've been used. Let's work with the number 3 now. And you can see that they both have a pair of 3s. So again, we can put 2 3s in the center there, and we can cross this out. And the remaining ones will now go in the allocated sections. So again, if I take the blue color here, you can now see we have 2 and 2, which is going to be in the 72 section. We then have the 5 for the 90 section and the 7 for the 126 section. So now given that, if we work out the highest common factor, we need to multiply all of the numbers in red here. So 2 times 3 times 3 will give us 18. And that is our answer there. Marvelous. Okay, let's move over to the last section now. So Kenny is thinking of 2 numbers that are greater than 10. And he says the highest common factor of these 2 numbers is 7. And the lowest common multiple of the numbers are 84. So as the lowest common number is 84 here, I'm going to go ahead and work out the factor tree of this. Okay, I now have my digits, and let's go ahead and put this in and label this A to B. So again, as you can see, the HCF of the 2 numbers are 7, and that matches with the number 84. So 7 can now be our HCF, and now that's crossed off here. And because now Kenny is thinking of 2 numbers greater than 10, we have to make sure that the product of A and the product of B is greater than 10. So let's put 2 and 2 in A and a 3 in B. So now if we work this out, we'll have 2 times 2 times 7, which is 28, and 7 times 3, which is 21. And you can now see the 2 numbers can be 21 and 28. And there we are. That now brings me to the end of our video here. It's been a wonderful session where we've gone through a range of different questions, covering both the highest common factor and the lowest common multiple. Please remember, with these Venn diagrams, they're showing the relationship between different sets or categories of data. And they can be used to calculate the highest common factors and lowest common multiples of numbers. I hope this video was useful, so don't forget to like and subscribe our channel for more useful content, and feel free to comment below for any other topics that you would like me to cover. Your comments will only help me improve this. That will benefit you. So keep up the great work, and I'll see you in the next one.